Hey everyone, my name is Ronak back with another video, and in this tutorial you are going to learn logistic regression, that is your first classification algorithm. So this is the 11th tutorial in the getting started with machine learning playlist, and let's get started. So far now we have covered regression in detail, basically simple linear regression. Now let's move on to the classification. In this tutorial we'll cover logistic regression. Well, isn't it logistic regression? Even though it is logistic regression, it is a binary classification problem. So it is better that you understand the differentiation between the linear regression and logistic regression. Linear regression is a classification regression problem where you predict the continuous values, and logistic regression is a binary classification problem where you classify whether the particular thing is yes or no, true or false. The formal definition of logistic regression is that in statistics, the logistic model is used to model the probability of a certain class or event existing, such as pass fail, win lose, alive dead, or healthy sick. So it is yes no, 0 1, true false. Now this is linear regression, understand this. So you have a set of points in a linear fashion and you pass a linear line. So why for classification we cannot use linear regression? Because if it is binary classification problem, we have 1 and 0, so y can be either 1 or it can be 0. So definitely the points are stacked in that manner. So a linear line won't be able to cross and pass through all of those points, okay? It doesn't satisfy the problem, I would say. So we need an equation that passes the line in this fashion, that is in a curve, okay? So it is going to cover all the 0 as well as the 1 points. So that is logistic regression. We will see it in detail. The thing you see over here is known as a logistic function. So this function helps us to pass the line in this manner, just like we see in this diagram, okay, the right one, logistic regression. So this is a logistic function. It is also known as sigmoid function. So logistic function is a type of a sigmoid function, and sigmoid function basically passes line in a curve fashion. So logistic function is also known as sigmoid function. So it is given by this formula. So sigma indicates the sigmoid. So sigma of z. So z is equal to, so z basically is the function of the linear regression, because if you see, the linear regression equation itself is modified into that curve 1 by 1 plus exponential raised to minus z. So that is the formula of the sigma. So sigma of z indicates that I am going to place the z in raised to my exponential function, exponential variable, sorry, where z is an equation, obviously. So equation of linear regression, which is beta naught plus beta 1 into x of I. In our case, we will use function of linear regression and convert into logistic regression using sigmoid. So that is our goal. So we convert the linear regression function into logistic regression. So logistic regression is given by this. So z, basically the variable z, the equation is equal to beta naught plus beta 1 into x of I, which is the simple linear regression function where beta naught is a constant and beta 1 is a regression coefficient, and we get these values based on particular formulas. If you don't know, you can check the linear regression tutorial. I think that is the third tutorial in my getting started with machine learning playlist. Then sigmoid of z is equal to this formula, which is 1 by 1 plus e raised to minus z, which can be also expressed as this one. So 1 by 1 plus e raised to minus z, in which beta naught plus beta 1 into x of I is my z. So y pred is finally equal to sigmoid function, sigmoid of z. So that is my y prediction, y pred, okay, the value that I am going to get. So y pred is equal to sigmoid of z yields probability. So probabilities lie between 0 to 1, that is 0 to 100%. So we can set a threshold of 0.55, which can be also said as 50%. The logistic regression, we have to set a threshold. So based on that threshold, we can identify that particular points are going to give us the predictions as 1 and particular points are going to give us the predictions as 0. So we set the threshold to 50%, that is 0.5. So everything that lies below 0.5 to negative infinity gives us 0. So it is going to say 0, that is no, fail, false, okay? And anything that lies is equal to is basically equal to 50% or more than 50% till I would say positive infinity you can get the values, it is going to give us 1. So it is going to say yes, 1, true. So y hat basically yields probability. So probability of being 1 and probability of being 0 should be calculated. For that we set the threshold. Usually threshold is set to 0.5. So if y prediction is greater than or equal to 0.5, the prediction of y is equal to 1. And if y hat is less than 0.5, the prediction of y hat is equal to 0. So understanding a logistic regression with an example. Obviously every time we have to take an example so that you get the better intuition of the algorithm. So considering the prediction of classifying whether the student is going to pass or fail the examination based on the number of hours they have devoted to studying. So a particular student devotes some or the other hours for studying, and we have the examination outcome. So this is a supervised binary classification algorithm. So being supervised, it is going to learn from the data and then it is going to yield some output. So 0.50 hours per day, so the examination outcome is 0, that is the student has failed the exam. Similarly and this is just a generalized data, a simple example, but usually we use a massive example. Okay, I can start this by preparing this table. So this is exactly the same table as the linear regression one. So first of all we start by taking the mean of x and mean of y, and I get the mean. Then I calculate x of I minus x mean. So I use each and every value minus my x mean. Similarly I do it for y, then I square both of them, and I also take x of I minus x mean into y of I minus y mean. So I create the table like this. Okay, so this is the basic table. You can do it. I have calculated by myself using my calculator, and I have also taken the sum of all of those. Now I calculate the beta 1 and beta naught. So beta 1 is my regression coefficient, which is x of I minus x bar into y of I minus y bar by x of I minus x bar the whole square, which gives me 0.2615. And then I calculate the beta naught, which is my constant. So it is y mean, the mean of y minus the regression coefficient into the mean of x. I am extremely sorry, it is a mean of x. In my PPT here I have said x of I, so it is a correction. So it gives us 0.5 minus 0.2615, that is the value of my beta 1, into the mean of my x bar. So that is 2.83, which gives me 0.240045. I put this into my z. So I create the linear regression function. I use it as it is. So beta naught plus beta 1 into x of I, which gives me minus 0.24045 plus 0.2615 into x of I. And then I actually pass it to the sigmoid function. So basically y prediction is equal to sigmoid of z, which is 1 by 1 plus e raised to minus z. Similarly I replace the function. Similarly I replace the values. So this is my function. Let us take an example. So predict the status of examination outcome where the student was studying for 2.7 hours on daily basis. So we want to find that whether the student is going to pass or fail. I use the formula. So y prediction is equal to sigmoid of z. So I replace the values in my function. So I replace the 2.7 into x of I, and I get 0.6144, which is 61.44, and we have set the threshold to 0.5. So it is above 0.5, definitely it is greater than 0.5. So this exceeds the threshold of 50%, which indicates the outcome is 1, i.e. the student is going to pass based on 2.7 hours of preparation on daily basis. Similarly, I'll take a fail example, so where the student fails. So predict the status of examination outcome where the student was studying for 0.75 hours on daily basis. So I replace the 0.75 into my x of I. So y pred is equal to 0.4890, which is 48.90% probability. So this does not exceed the threshold of 50%, it is below, which indicates that the outcome is 0. In essence, the student is going to fail based on 0.75 hours of preparation on daily basis. So this is the most basic and introductory explanation of logistic regression, and we will cover the logistic regression more in depth in the next tutorials. First I will be implementing it in the raw Python, and also I might get into more deeper math of the logistic regression in the future tutorials, I don't know. So I think this is it for this tutorial, and if you like my content, please do subscribe to my channel and gain the knowledge, spread the knowledge. So thank you for watching. Goodbye.